title of your notes is going to be writing absolute value as piecewise. Have you ever heard of piecewise? Okay. Piecewise, so Piecewise, all as one word, piecewise. Piecewise. Okay. So first what we're going to do is we're just going to draw a sketch of y equals the absolute value of x. And I know that you're probably not doing this on graph paper, so if it's not perfect, that's totally fine. So an absolute value graph starts at 0, 0, right? That's where the vertex is. And then where does it go from there? Yeah, it goes up 1 over 1. And up 1 over 1. And it does the same thing in the opposite direction. And it makes that perfect V-shaped graph. Okay, so we're going to say the vertex of a regular absolute value graph is 0, 0. Okay, so what we do to write a piecewise function is we say I can take this graph that's already drawn and I can split it in half and I can say that it's one linear function connected to another one. So I'm going to say this is one line and it just happens to stop at 0. You guys listening? You ladies? Listen. Okay. And this is the other line and that one starts at 0. So we have two different lines and they're two different pieces and together those two pieces make this graph. Okay, that's what a piecewise function is. It's just saying we can make a graph that's based on more than one piece. We start off with absolute value functions because they're the easiest piecewise graphs we can really work with. And then throughout the year, they're going to get more and more complicated because we could have a piecewise graph that maybe has one piece that's linear and one piece that's a quadratic. You guys remember what quadratic graphs look like? Those are they're like U-shaped, right? So, or we could have a piecewise function that has one line and then an absolute value graph and then a quadratic and then another line and then another line and then another quadratic. That could be a piecewise function. That would just be a lot of different pieces. Does that make sense?
Wait.
Okay. Yes.
So is there any specific things that they have to meet? So like does it have to have X amount of spaces of something or changes?
No. You could have like each individual piece could be literally a dot. It could be one single point. Yeah. Okay. So we're going to think about what the equation of this line on the left would have been. So if we cover up this part, what is the y-intercept of that line? 0. And what's the slope?
1.
It goes down 1, right 1, down 1, right 1. Right? Okay. So if I write that out, I'm going to say this is negative 1x plus 0. Right? That's the equation of that line. And I'm going to say that is only if the x value is less than 0. Because that's how I can get just the left side. Okay? So I'm going to say if x is less than 0. Okay? If I cover up the left side and I want to write the equation for this graph, what's the y-intercept here? 0. And what's the slope? Just 1. So then I'm going to say 1x plus 0 if x, and how do I show that the x is on just the right side? If x is greater than 0. Okay. Now, based on how we wrote these pieces, it kind of looks like x is never supposed to be 0 exactly, which would mean there would be like a little hole here. Do not draw this on your paper. I'm just showing you what it looks like. If we were to get graph what we wrote just there, it would actually look like this, and we would have a hole in the graph and it would not be filled in. But that's not what an absolute value graph looks like. It's not. So what we typically do is we choose one of these and we just put an equal to with it. Okay, so we're going to put the equal to with the top one. That would fill in that hole. And so the left side is the negative straight line. The right side is the positive straight line. Okay, and then to show that these two pieces happen at the same time, we put a little squiggly bracket. That's the technical term, squiggly bracket. It's not, I lied to you. And we're going to put f of x equals in front, or you could put y equals. It doesn't really matter. Now, most people don't put the 1 in the front and they don't put the 0 on the end, right? We did that so we could help ourselves think through like, oh, there's a y-intercept and I can find it, and there's a slope and I can find it. But most people would have written this as negative x if x is less than or equal to 0, and positive x if x is greater than 0. That's how most people would have written it. Yes?
So why would you do this?
So the context of like why we need these is going to come when you get into more advanced class. There are some skills in math you can't possibly do to an absolute value problem. You have to do it to a piecewise function instead. We learn how to break these apart now, but one of the things we study in Math 3 is like how to look at all sorts of different pieces together. So this is just like a very simple version of a piecewise graph. We're going to get more complicated. All right, so we're going to do another example. We're going to say y equals negative 2 times the absolute value of x. And we're going to go ahead and sketch this. So this one still has a vertex at 0, 0. Do you guys remember what it does from there? It goes down because it's negative. So down 2 over 1. So this one has been stretched. Down 2 over 1. Okay. Okay. So again, we have the left side and we have the right side. So when we write the piecewise function, we're just going to write those two different pieces. Okay. All right. So when we write the left side, what is the y-intercept? 0. And then what's the slope? It's 2, because it goes up to right 1, up to right 1. Okay. So we're going to say 2x plus 0 if, and what x values are we interested in? If x is less than 0. Yeah, we can go ahead with equal to, so we don't have that hole in there. Okay. And then if we cover that up and look at the right side, what's our y-intercept? 0. And then what's our slope on this side? Yeah, so negative 2. Okay. So negative 2x plus 0 if x is greater than 0, because that's the right side. And then that's our piecewise function. Okay. All right. Now, instead of drawing these, I'm going to start going into kind of the shortcut way to do this, okay? So we know that an absolute value function is going to have 2 linear equations, and one of them is going to have a negative slope, and one of them is going to have a positive slope, right? That's what we know. Okay, so here's our next example. we're going to say 3 times x minus 5 plus 1. 3 times x minus 5 plus 1. Okay, and when I draw a sketch of it, it's going to be a very, like, not sloppy sketch, but it's going to not have very much detail in it. Can you guys look at this and tell me what the vertex is? So it's the opposite of this one, right? The positive 5, and then it's the number on the end. So it's positive 5, 1. So this absolute value graph went to the right 5, and then it had a vertical stretch of 3, so that makes it kind of skinny. Okay, so that's the graph. That's about what we have. Okay. So to write this as a piecewise function, I'm going to say that it should be the negative version of this, because first for the left, because this is a negative slope. Do you guys see that? So I'm going to put in front of this, and then I'm going to say 3 times x minus 5 plus 1. And if I cut that in half, what's the x value where it stops and changes directions? This x value right here, 5. If x is less than or equal to 5. Okay, so that's the negative part, that's the left side. Then I'm going to do the positive version if, what do you guys think? X is greater than 5. And we can't say or equal to because we can only have the equal to on one of them. It doesn't matter which one you put it to, just it has to be one or the other. Okay. Now, can we simplify this math a little bit? Yeah, we can distribute, right? Okay. So if I'm looking on this one and I distribute the negative 3, what do I get? Negative 3x plus 15, and then we have the plus 1 on the end, right? Okay, so negative 3x plus 16. Okay, and then for the other one, we'll go ahead and distribute the 3. So that's 3x minus 15 plus 1, which you're right would be minus 14. Mm-hmm. So to write my final answer for this one, I'm going to say f of x equals negative 3x plus 16 if x is less than or equal to 5, and then positive 3x minus 14 if x is greater than 5. How are your brains? Tired? They okay? Falling asleep? No. Okay, we're going to do another one. I think once you pick up on it, once you pick up on it, I think you'll be like, that's easy. But it's like your brain is sorting through it right now. Okay. We got it written down? Okay. All right, next example. All right, this time I'll do f of x equals, does not make a difference. You can use either notation. It doesn't matter. Okay, so for this one, we'll say 2 times the absolute value of x minus 1 plus 6. Okay, so where would the vertex be? Yeah, positive 1, positive 6. So if we were to think of a little sketch of this, we would go to the right one up 6, and then it's vertically stretched by 2, so it's going to be kind of skinny. It's going to look something like that. Okay, so our piecewise function, we have the negative version on the left side. So I'm going to say negative, and then 2 times x minus 1 plus 6. If, and what's the x value where it changes directions? 1. If x is less than 1. Less than or equal to. And then we'll do the positive side for the other one. So then we have 2 times x minus 1 plus 6 if x is greater than 1. Okay, and then what do we need to do from here? Yeah, we got to clean it up a little bit. So we'll say negative 2x and then plus 2 plus 6. Yep, so it'll be negative 2x plus 8. And then this one is 2x minus 2 plus 6, which is 2x plus 4. Yep. Okay. Did that one feel a little easier that time? Much easier? Okay. Now, I'm going to show you one with a negative in the front because it makes it a little funky. Okay? So this time we're going to do f of x, and we're going to put a negative 2 in the front. Okay. So what's the vertex? Negative 1, negative 3. Okay? So if we think of this graph, our vertex is left 1, down 3. And then it has a negative 2, so what does that do? It turns it upside down and it's still stretched out. So it'll look like this. Okay. Now, we typically say for the first equation, you should put a negative in the front, right? This one already has a negative in the front. So when you put another negative in the front, what happens? It turns it positive. How does that make sense? Because it's positive, right? It should be positive first thing on this one because it's upside down. So if you follow the pattern, it's going to work regardless. Does that make sense? So this graph is negative already. We put another negative in front first because that's what we always do. And the negative actually makes a positive, which matches what we wanted. What's the x value? Close. Negative 1. And then we do the positive version, which actually means we're just not going to put a minus in the front. We're going to keep it normal. And so that fits what we want it to have because the right side really should be negative, right? Okay. Okay. All right, so minus minus, those basically cancel each other out. I'm going to go ahead and make those a plus. So again, we're going to show all that stuff. So we've got 2x plus 2 minus 3. So 2x minus 1. And then down here we have negative 2x minus 2 minus 3. So negative 2x minus 5. Okay. All right, what do you think? Good? Okay. So now we're going to go back to the sheet of paper you were doing your previous activity on. We're going to do another activity. All right, so on your paper, you're going to put an A, and we're going to say f of x is the absolute value of x. And you're going to ignore this top part right now. That's clear. That's not the right answer for this. You're going to ignore the top part. And what we're going to do is we're going to find the piecewise function for this, which should be pretty easy because we already did it. Okay, so what is the piecewise function? Just to remind you guys, it looks like this. We have the vertex is 0, 0. So our piecewise function is going to be f of x. And what do we do first? We do the negative version first, so that's just going to be negative x. If x is less than or equal to, what's the x value in the middle? 0. And then we do the positive version if x is greater than 0. Okay, so now what you're going to do is you're going to look for the card that has this piecewise function written on the top. So look through. Somebody let us know if you figure out what letter it is. It is not L. It's very, look at it, compare it with L.
Yeah.
See how it's a little bit off? So it's not L, it's a different one. It's I. It is I. Okay. You guys see that? So we have to be careful because L was very, very similar, but the symbols were wrong. You guys see that? Okay. So now we're going to do I next. So let's write I on our paper. So A goes first, I goes second. No, it's just that they go in a specific order. And so if you show me the order, I can tell you if you got them right or not. Yeah. All right, so we've got f of x equals negative 3 times the absolute value of x plus 1 plus 3. And what's the vertex? Okay, so negative 1, positive 3. So if we draw a little sketch of that, it's going to go left 1 and up 3. And then what does the negative 3 in the front do? It flips it upside down, and it's going to make it pretty stretched out, right? It's going to look tall and skinny. Okay. All right. So to write our piecewise function, what do we do first? We do the negative version, and it's already negative, so we're going to have the negative version of negative 3 times x plus 1 plus 3 if and then we look at the x value, switch directions, -1. So we're finding the vertex because the x value of the vertex is where it switches. That's why it's important to find the vertex every time.
Wait, how do you do that?
If x is less than or equal to -1, and we got that from the vertex. That's where it switches. Okay. And then we say the positive version, which happens to just keep the negative in front of it because it was already there. If x is greater than -1. Okay. And then we got to fix it. So go ahead and fix it. And then once you have it, you're looking for the next card.
Can you put -3x plus 0? Or is it
You can put +0. Yep. Okay, and what card goes next? G. G goes next. So the answer from G . Okay, you guys okay? We understand how it works? Okay, so we're just going to do as many as we can before the period is over, and then we will pick up with it again first thing tomorrow. Okay. Yes? Your homework, great question. Actually, this is a good announcement. So if you look at the board, you can see it says quest on Thursday. Yes. You might wonder what a quest is. It is halfway between a quiz and a test. A little bit longer than a quiz, less than a test. What'd you say?
It's like a real quest is graded?
It's graded, yeah. Because we are close to the end of our unit. Like after this, we have to learn word problems, and then we're like done. That's it. So one thing you can start working on, I let students use what I call a cheat sheet for a portion of each assessment. Not the whole time, but for the last 10 or 15 or 20 minutes. So what I like for the cheat sheet to be is like a one-page summary of what you've learned, all right? I don't give you credit for that, but the benefit of that is that you have it so that you can use it on your test. At the end of the semester, you guys have an EOC, like the state exam, like the big one. And so then when we get to the EOC, you will have a cheat sheet for each unit, and it makes it way easier to study for the EOC. Does that make sense? Yes. So I think what I will work on is I will put a checklist of what should probably be included on your cheat sheet up on the website, and that could be what you work on tonight to prepare you for the quest, which is on Thursday. Does that make sense? Okay. So the way that I have things graded, you've got like a quiz grade. A test is like a double of a quiz grade. A quest is like 1.5 quizzes. That's how I like grade things. Does that make sense? Okay. Any questions on that? So the stuff that would be on the quest is anything that we've learned so far. That's like what, yes.
So our homework is to do this cheat sheet.
Yes. Yes. Yep. So, and I'm just going to say, because I don't have other homework for you, that's like the best use of your time is to do that. Okay. Any questions? All right. So for the next 5 minutes or so, you're just going to see if you can get 1 or 2 problems done, and then we'll pick it up tomorrow. Okay? All right.